In Windows, there are two types of disk volumes. One is a basic disk, and the other is a dynamic disk. The characteristics of a basic disk: it contains partitions. That term partition is synonymous with basic disk. Now, what that actually means for me, in my computer here, I have three drives: disk 0, disk 1, and disk 2. The first hard drive in your computer is always labeled as disk 0. All I can do, if all three of these are basic disks, let's say this is 500 gigs. Well, let's say each drive is 500 gigs. Well, I could have a C drive here that is, say, 200 gigs. I could create a D drive that is 300 gigs. Now, we know the sizes are not exactly that, but all you could do is take this one drive and you could further partition this drive so part of it's the C, part of it's the D drive. You could go to disk 1. Same thing though. Now let's say this one is 500 gigs as well. All you could do is partition this and create other drives. So I'll say this is the E drive, that's F. And we'll say, G and H. But all you could do is further partition these. So the key takeaway here: you have 1,500 gigs of space in your server, but you have no block of space that could be any larger than 500 gigs because you don't have a way to combine the space from these disks. Sometimes what we need is to be able to combine space from multiple drives just so I have a larger block of space to actually work with. That's where dynamic disks come in. With a dynamic disk, let's say my C drive is just all on disk 0. And we'll say again, that's 500 gigs. Disk 1 and disk 2, we'll say they're 500 gigs each as well. But what I can do now, with a dynamic disk, they do not contain partitions. What I always say for a dynamic disk, volumes contain dynamic disks. So we do not use the term partition. We use the term volume. And now my volume can contain multiple disks, actually up to 32 disks in one volume. So what I could do is take disks 1 and 2, and I could combine those into the same volume. Now we said each one of those disks is 500 gigs. So that's roughly 1 terabyte, just under 1 terabyte actually. But we're just going to say 1 terabyte because it's easier to say. So I have about a terabyte of space on these disks. When I put them in the same volume, this can be my D volume. But it actually contains both of these disks. So you can do that for up to 32 disks that could reside behind one drive letter. Compare that with a basic disk. With a basic disk, all you can do is take the disk and create partitions on it. With dynamic disks, you create a volume, then you add volumes to the disks, and you can get massive amounts of space. Petabytes of space we could actually have. Pretty interesting concept. Once you start using dynamic disks and you've made that conversion, there are different options you have for the configuration of the dynamic disk. So we have these volume types that we can define. Now, the requirement to do any of these is that you have a dynamic disk in your system. If you have a basic disk, you cannot do any of these. Now, if you're on any system, even Windows 10, you can simply go to Computer Management. So I'm just going to right click my Start button, and Computer Management's in the list. Or you can go to Disk Management. Computer Management has Disk Management within it. This setup is the same on Windows 10 as it is in Server 2019. So even the local machine you're watching this course on, if you open your Computer Management, go to Disk Management, you'll see right now, you're always going to have a disk 0 because your operating system's on it, but you'll see it says basic. you'll see there is an option to convert to dynamic. Now, you don't want to click that on your own machine because it's going to force you to reboot. But when we say basic dynamic, that's all we mean. Basic, always the default when you install the operating system, but anytime after that, you can convert to dynamic disk. And you'll even see here, there's option for new span, stripe, mirrored, RAID 5. They're all grayed out because I'm not a dynamic disk and I don't have multiple drives in my machine. But that's all we're talking about here. These types of volumes we can actually use. The first one we're going to talk about will be a simple volume. A simple volume is just one dynamic disk. So there's really nothing to say about that. On my local machine, if I had converted my disk to be dynamic, we would call it a simple volume. Just one dynamic disk. There's no real benefit to actually do that, so normally you don't ever see that actually. The benefit comes when you have multiple disks. If I wanted to take these disks, again, we'll say each one is 500 gigs. Now, they do not have to be the same size. That's not a requirement for Microsoft. But I can have these combined into a span volume. Now, the way a span volume works, let's say this is the D drive. A span volume will write to one disk only. When this disk is full, it then starts writing to this other disk. So you truly have one block of space that's just under a terabyte in size, but it does not give you like a performance increase because one drive is reading and writing. When that one drive is full, it then starts using the other drive. For that reason, a span volume is not very common. Much more common than a span volume will be a striped volume. The way a striped volume works, you have your multiple disks up to 32, as we said, and we'll say that's the D drive again. When you start saving data, it'll concurrently save data to both disks. So these disks here basically will fill up together, or at the same time, we should say. Roughly half your data is written to one disk, the other half to the other. The benefit to that is you do get a performance increase. So span is an option because Microsoft said it's an option. If you were doing this, 100% of the time, stripe is what you would choose when given the choice between only those two, because you get a performance increase and you still get the same amount of space. There is no downside to a striped volume in any way. You don't even often hear this span volume. It's omitted from a lot of documentation because it's just not an option you would normally choose. Now, there is no redundancy with spanned or striped, meaning whichever one of those you selected, if this drive failed, then the D volume would be inaccessible. Now, that makes sense in this picture because half your data would have been written to the D drive. But let's say you're doing a span volume and you have not yet written anything to this drive. Everything's just on this drive. Does not matter. If this drive fails, even if you've not written any data to it, from its point of view, one of the drives that makes up the volume is inaccessible. The entire volume has failed until you restore from backup. So whichever of these you choose, there is no fault tolerance. So that's something to keep in mind. When we want to start looking at fault tolerance, we will look at mirrored volumes. The way a mirrored volume works, you could have your C drive here. You add another hard drive. Now I'm just going to call this the mirror. It copies everything from the C drive to the mirror. So if you save a file here, that file is automatically written to the mirror. The operating system lives here. So your entire OS lives on both drives. Any data you create lives on both. When you install applications, your apps would be on both. The benefit of this, if my C drive, we'll call that disk 0, and we'll say this is disk 1 in our system. If this drive mechanically fails and crashes, you can simply reboot and boot from this drive, and it has an exact copy of all your data. So you are protected from mechanical failure. Your only downtime would be the time it takes to reboot and choose to boot from this other disk. So the mirrored volume we would always use for the operating system. And typically you would only use it for the operating system, because if both of these are 500 gigs of data, you have purchased, essentially for every 1 gig of data that you use, you've purchased 2, because this is just a mirror. So that, when hard drives were more expensive, that was always a concern. Like if you had a file server with massive amounts of storage, it may have been cost prohibitive to mirror all the drives in your file server. When we look at data, RAID 5. Now, sometimes this is called a stripe with parity. RAID 5 requires a minimum of 3 disks. And the way it actually works, when I save data, I can have data written to this first disk here, but part of this is also going to be parity information. Now, this parity is heavily compressed information from other drives. So here, I'm going to call this data A, and I'm going to call this just data B, but I'll just write B. Well, if I go to my other drive, we'll just say that has C, has some parity, and then has just a data block I'm just going to call D for the sake of my picture. The last drive has some parity. Then it has just these other blocks of data. Now I put these other blocks of data here just to illustrate the parity. But the way parity works, when you have data that you save, it gets striped across all 3 of these disks. So some of your data is written to disk 1, some to disk 2, some to disk 3. This parity information is actually heavily compressed data that was stored on other drives. So here, you just choose a different color for my stylus. The way this works, let's say disk 2 were to fail. Well, you have data here in what I just call block C. That data can be recovered from this parity sector here. The data in block D, I can recover that from parity on disk 1. Now, this parity is really just a copy of the data in a heavily compressed format. So you can't open the parity and actually read it. But what could happen? We replace this hard drive. So we'll say it mechanically failed. But as soon as you replace it, the parity from the other drives automatically recreates all the data on that drive. So you don't have to restore from backup or anything like that. So pretty interesting. Now, to summarize these overall, simple volume, we said that's just one dynamic disk. Span volume, we're going to say just no, not an option you would use. Now, since it's not an option you would use, you may think, well, why do we talk about it? Because it comes up, you see it in the interface as an option sometimes you can choose. So we just want to know how it works so you know why you don't actually choose it. Stripe, similar to span, but you do get a performance increase because it concurrently writes to both disks. Now, with the spanned and striped, these can never contain an operating system because the operating system cannot span more than one drive and it cannot be striped across more than one drive. So both of these options, spanned and striped, can only be for data drives, just files and folders. A mirrored volume is for the operating system. That's where you're going to see that. And this RAID 5, or stripe with parity it's sometimes called, just says RAID 5 in the interface, that is only for data as well. So of all of these in the list, the only one that can actually pertain to, say, the C drive, where your OS is installed, mirrored volume and simple volume, that's just one disk, so the OS could be installed on that. Span, stripe, RAID 5, data only. Now, I'm sure some of you work in IT already. Microsoft uses these terms in the interface, but the industry standard term for this is RAID. A simple volume does not have a level of RAID, but the spanned and striped we talked about. In terms of RAID, they would be considered RAID level 0, which means they are not fault tolerant. The mirrored volume is RAID 1. And the stripe with parity we mentioned, that's RAID 5. Now, weirdly, in the interface, Microsoft refers to RAID 5 as RAID 5. They just don't use the term RAID 0 or RAID 1. So the reason I mention it, this is an industry standard, or these terms. You'll hear RAID 1, RAID 5. If you go to the Dell website and look at a server, they'll tell you, oh, we support these RAID different configurations. Now, one key takeaway. If you go to the Dell website and they tell you this server supports, RAID 1 or mirroring for the hard drive, RAID 5 for a certain number of disks that you want to connect to store data, they mean hardware, where physically the motherboard or system board on those servers has controllers in it that manage which drives data gets written to. In Microsoft, we are using what in the industry we call software RAID, although Microsoft really does not use that term. What it means is it's completely managed by the operating system, and it really has no relationship to the hardware configuration in your system. You just slap a bunch of drives in your server, then you go through Windows and configure this. Where many servers, it's all set up based on the hardware in the server. So at Microsoft, just know, whenever you mention RAID within an operating system, you're talking about a software configuration. Pretty fascinating.